In this video, we are going to continue to work with lines and planes in 3 dimensions. I'm actually just going to give you guys 2 problems to do. You'll do them like board work style. And then I'm going to show you how to do a third problem. So your first problem is actually already up. I want you to find the equation of the plane containing the 3 points, 1, 1, 1, that's P, Q at 2, 3, 5, and R at 3, 2, 2. There's a way to make all of your vectors positive, and if you can see that, then you should do it that way. I'm gonna pause and do the whole thing. I want you to pause right now as well, because your answers are just gonna pop up in a moment. Go ahead, pause. Here come your answers. Here it is. I got negative 2x plus 7y minus 3z is equal to 2. One way you can check your answers is if this thing contains all these points, you should be able to plug them all in to this equation here, to this left side, and get 2 out. So for example, if I plug 1, 1, 1 in, notice I get negative 2 plus 7 minus 3, and that in fact gives me 2. If you were to check it for these other 2 points, it would work. So it definitely does contain those 3. And you can do that check on your own. But maybe I should have said this in the beginning. I don't want this form of the equation. I always want you to give it to me in the form that I have down here in the box. All right, so what did I do? I found A. That was P to Q. 1, 2, 4. It was just how far is this? That's 1. Change from 1 to 3 is 2. Change from 1 to 5 is 4. And then I found B, and it was from P to R. The reason I started at P is because it was easier, and the 1, 1, 1 was smaller than all the rest of these numbers. So I knew I was going to get positive values for my vectors. So after I got those vectors, I crossed them. That's my normal vector. This goes here, this goes here. You could flip them the other way, and you would just get a negative version of this vector here. So the reason I wrote these things in red is because I wanted to emphasize the structure that I use when doing my cross product. I like to draw my brackets with my little deets inside of them, and I like to make sure that I don't forget this negative. And then I get this like this. So we get negative 2, 7, negative 3. Then those 3 numbers go here respectively. And then I want to take the easiest of these to work with. So in this case, it's P. That's why I have an x minus 1, a y minus 1, and a z minus 1. If I had used Q, then for example, this z would have had a minus 5. And it would have given us the same thing either way. Anyway, simplify that. I prefer to keep the variable things here and then write the other pieces here. I do not like doing that step in my head because I know I personally will always mess that up. And I got this right here. So let me put your next question up. One thing I should have said about that previous one is that as long as your answer is a multiple of this, your answer is good. For example, I could double everything here, and it would still be an equivalent equation, so that's correct. So negative 4x plus 14y minus 6z equals 4 is good too. So if you had a different answer, you still could have been correct. So speaking of things with multiple answers that are correct, in fact, infinite answers that are correct, this problem right here also has an infinite number of correct answers. I think there is 1, maybe 2 that you are most likely to get to. I want you to find the equation of the line through these 2 points. You can do just the parametric form. You do not need to give me the symmetric form. So again, the answer is going to pop up in a moment. I want you to hit pause, do the problem yourself. Okay, here comes the answer. So this one is a little bit less work, so there's not as much writing here. And in fact, you don't even have to have this. This is the answer that I think is most likely for people to get to. What I did, I found my vector from the first one to the second one. You can see this worked. From 2 up to 5 is 7. From negative 1 up to 5 is a positive 6. From 0 up to 8 is an 8. So those become the slope pieces of my parametric equations, the things with the t's on them, 7, 6, and 8. and then I just need to take a point on the line. So the easiest one for me was this one because these guys were positive. Now, you totally could have taken this point instead, and then your z equation actually is a little bit more simple, but you got these negatives. So if that's what you had, you're correct. I just wanted to have those positives because it made me happier. So, you could have had, instead of 7, 6, 8, you could have had double everything or triple everything or negative everything, right? And as long as yours is a multiple of this, and those are on the t's, and then hopefully you just used either this point or that point, then yours is correct. So what I'm going to do now is show you how to do a problem with the answers from these two problems. So I'm going to copy my equation from the first one, and I'm going to copy these, and then I'm going to ask you to do something with them. Okay, so I want you now to find the intersection of the plane from question 1 and the line from question 2. In order to convince you that they have to intersect with each other, well, they don't have to. There's one scenario where they wouldn't, but hold up a sheet of paper in the air. Okay, that's your plane. Imagine it extending out for forever, right? In all directions, right? Well, in 2 dimensions, right? So it's flat still. And then hold up a pencil and imagine extending that out for forever, right? Well, you should see that pencil is going to hit that plane. That is, unless the pencil is actually parallel to the plane. That's the only scenario where it would not hit. But what we are going to do right now is, these two are not parallel, so it doesn't matter. But we are going to find the intersection of these two. And it's actually quite intuitive, I think, at least. Look, I have, and we'll go to green. I have an x right there, a y right there, and a z right there. Usually when we want to solve for when two things are equal, we need to get rid of some variables or something like that. That's what you do with elimination when you find a system of equations that's equal to each other, right? Or when to solve that. But look here. Do you see that I have x in terms of t? So what I can do is plug in this 5t, or 5 plus 7t, in for x right there. Same thing here. I'm going to plug in this guy. And then same thing here. I'm going to plug in this guy. So when I do that, when I basically like that, I get -2, open parentheses, close, and I'm going to put my 5t, or 5 plus 7t in there. And then plus 7 times, 5 plus 6t. And then minus 3 times 8 plus 8t. And then I get my 2. So you may say, all right, what do I do with this? Well, look, now I've only got one variable and one equation, so I can solve for the t value. So that t value is going to give me the time in this set of parametric equations right here that makes this line equal to this plane right here. So all I have to do is solve for my t value, and then I plug that t into here, and it gives me my points. Let's do that. This is a -10 minus 14t plus 35 plus 42t minus 24 minus 24t equals 2. And then if I move everything over, well, if I combine all the terms on the left side first, I get 4t plus 1 is equal to 2. Move that over, 4t is equal to 1. T is equal to 1/4. So from there, all I got to do is plug in t equals 1/4 to this. If I do that, I get x equals 5 plus 7/4, which comes to be 6.75, or you could leave it as a fraction if you want. Y is 5 plus 6/4, which is 6.5. And then z is equal to, what is z equal to here? 8 plus 8/4, which that's nice. It's just 10. So That's my point. Those are my points. It is 6.75, comma 6.5, comma 10. Now I explained in one of the ones up above, in the first question, how to check your answer. How do you think you would check your answer here? Well, I think it should be pretty clear that this point is on this line right here, right? So what we're really, because we just did that, unless we mess something up here, this point should be on that line. What we really want to do is check to see if we got the right t-value, if all this work is right. So what can I do? I can plug into my calculator these values right here in for this. So -2 times this, plus 7 times that, minus 3 times that. Hit enter. Do we get 2? We do. Or I know I do because I already tried it to check it to make sure I didn't mess this up before I did this video. Anyway, it works. And hopefully this is an intuitive process. Hopefully you got a little bit of practice with planes, with lines, and now you're ready to do some more things with them.